So we're going to go and look at the review sheet. I'm doing this as an additional video on top of what we're going to do during the review day, but just so that you have all of them. Now, whenever we factor quadratics, first thing we look is for a greatest common factor. We look to see if there is a number that will go into all three. And a negative, if there's a negative in front of b squared or x squared or whatever the variable squared is, we can factor that out. Now for the first one here, we do have a greatest common factor of 7, and we're going to divide it out of all three terms. So we divide 7 out of 7b squared, which will leave us with b squared, minus 63 divided by 7 is going to be 9b, and 7 divided by, or 140 divided by 7 is going to be 20. So that's our first step. Our second step is the two sets of parentheses with 3 spaces. Now we do need to make sure we keep the greatest common factor all the way to our answer. It will be a part of the answer. Now our third step is the signs. They're going to go in both parentheses. If the third term is positive, the signs are the same and they match the sign of the middle term. Now, if the third term is negative, the signs are opposite. Opposite signs. And if we look at this here, the third term is positive, so the signs are the same and they match the sign of the middle term. So it'd be negative and negative. And that brings us to our fourth step. Again, fourth step. Find the factors of the first and third term. Find the factors of the first and third term. So here our first term is b squared. Well, the only factors of b squared are b and b. Factors of 20. We have 1 and 20. 2 and 10. 3 doesn't work, but we do have 4 and 5. And out of all these here, I'll pick 4 and 5 first. And that does bring us to the last step, which is to check. Check to make sure that it does work. And when we check it, we're really checking these two here. B times negative 5 is negative 5b. Negative 4 times b is negative 4b, which gives us negative 9b, which is the middle term that we wanted. So these here are the factors, and we do need to include the 7. And that's all we have to do for this one here. Okay. Already saw that there. We'll go on to the second one. So we look at this here. Again, the first thing we're looking for is the greatest common factor. And between these three here, there is a greatest common factor of 9. And if we factor 9 out of 9r squared, we're left with r squared. If we factor 9 out of 36, we're left with 4. And if we factor 9 out of 45, we're left with 5. So we get r squared minus 4r minus 5. Now again, our second step is our two sets of parentheses with 3 spaces. Now to find the sign for step 3, we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. So one's positive, one's negative. And again, it doesn't matter which one's positive, which one's negative. We just need to plug it in and then check. Now the next step, step 4, is to find the factors of the first and third term. So the factors of r squared are r and r. The factors of 5 are 5 and 1, and we can just plug it in because r squared only has one set of factors, 5 only has one set of factors. And we can check r times -1 is negative r. 5 times r is plus 5r. Negative r plus 5r is a positive 4r. Well, hold on. We wanted 4, but we want it to be negative. So what we have to do is switch the signs. Because again, if we get the correct term, correct number, but wrong sign, we just need to flip them. And if we check this again, r times 1 is going to be positive r. Negative 5 times r is negative 5r, which this time gives us a negative 4r, which we wanted. So this here is our answer. And that's it. Let's look at the next one, number 3. And again, our first step is to check for greatest common factor. There is a greatest common factor between 3h squared and 6, but not between all three. So we can move on to step number 2. 2 sets of parentheses with 3 spaces. Now we look at the signs. We want to find the signs. If the third term is positive, which it is, the signs are the same and match the sign of the middle term. So we have plus and plus. Now we look at the factors of the first and third term. Well, the factors of 3h squared, well, h squared is going to be h and h. And the only factors of 3 are 3 and 1. Now the factors of 6 are 1 and 6 or 2 and 3. Now I can pick 2 and 3. I'm just picking 2 to start with. And we can check it here. 3h times 3 is 9h. 2 times h is plus 2h, which gives us 11h. Positive, which is what we wanted. So these here are our factors, and we're done. Now, if we picked a different setup, again, we checked it and multiplied out to see if we get the correct middle term. If we don't, then we need to try it again. But that's it for that one there. Now, if we look at number 4, again, we're trying to find greatest common factor between these 3 terms. To start with and factor it out. Well, there's not one between these 3. So we can do 2 sets of parentheses with 3 spaces. And again, our third step is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, the third term is positive, so the signs are the same and they match the sign of the middle term, which will be minus and minus. Step number 4 is to find the factors of the first and third term. Well, looking at the third term is just 1. Well, its only factors are 1 and 1. Now, looking at 6x squared, well, the factors of x squared are x and x. And again, I'm picking these 2 here because 1 only has 1 set of factors. We can plug those in. The only factors of x squared are x and x, so we can plug those in. Now, the factors of 6, as we already said, are 1 and 6 or 2 and 3. I'm going to start off with 2 and 3 because I know the middle term is small. So we can try this here and check to see if this works. 2x times -1 is -2x. -1 times 3x is -3x. And -2x minus 3x is -5x. That is the middle term that we wanted. So that is it for that there. Number 5, so again, looking at this here, we look for a greatest common factor between these 3 here. And there's not one between 3, 5, and -2. So we move on to step 2, 2 sets of parentheses with 3 spaces. Now we look at the sign. If the third term is positive, the signs are the same and they match the sign of the middle term. Here the third term is negative, so our signs are automatically opposite. Now we look at the factors of the first and third term. Well, 3n squared, well, we'll know we'll have n and n. Well, the only factors of 3 are 3 and 1. Factors of 2 are 1 and 2. So again, I just threw these in because I know at the end I'm going to check. 3n times -2 is -6n. 1 times n is going to be plus n. -6 plus 1 is -5, and we have n. But here we wanted it to be positive. So we did get the correct middle term, but we got the wrong sign. So what we can do is flip the signs, and that's going to change it here. 3n times +2 is going to be +6n. -1 times n is -n, which does give us a +5n. So those there are the factors. All right. Let's look at the next one here. And again, we look for a greatest common factor, and this time we don't have a greatest common factor, but because the -3, we have -3 in front of t squared, we're actually going to factor out a negative. We're going to divide each one by essentially -1, which is going to turn -3t squared into 3t squared. It's going to turn positive 11t into negative 11t, and it's going to turn -6 into positive 6. So we're really just pulling that negative out, which is just changing the sign of each of the three terms. And it's going to make it easier to factor. Once we pull that negative out, we can do our two sets of parentheses with 3 spaces. And then we look at the third term. If the third term is positive, which it is here, the signs are the same and they match the sign of the middle term. So negative and negative. Then we look at the factors of the first and third term. Factors of 3t squared, well, we'll know we'll have t and t. 3 and 1. Well, 6 is 1 and 6 or 2 and 3. And again, I could try 3 and 2. I'm just plugging them in, and then we can check. Well, 3t times -2 is -16. -3 times t is -3t. -6t minus 3t is -9t. Well, that's not what we wanted. So, okay, so I can switch the 3 and 2. So this time we have 2 and 3, and we can try it again. 3t times -3 is -9t. -2 times t is -2t. And -9 minus 2 is -11t. That's what we wanted, so we have our answer here. Now again, whatever we factor out has to be included in the answer, so the negative would need to be included there. Let's look at the next one. So if -4c squared plus 19c plus 5. Well, again, we don't have a greatest common factor, but we do have that negative, so we'll need to factor it out, which is going to change -4 into +4. It's going to change +19 into -19 and +5 into -5. And that was the only greatest common factor. Now we'll still have our two sets of parentheses with 3 spaces. Now to find the sign, we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Now we look at the first and third term. So 4c squared, well, we'll know we'll have c and c. Now with 4, we do have a few factors. We have 1 and 4 or 2 and 2. So I'm tempted to start with 2 and 2. Now the factors of 5 are 1 and 5. And we can go on and multiply this through. 2c times -5 is -10c. 1 times 2c is plus 2c, which gives us -8c. Well, that didn't work. We could try flipping it. And this time have 5 and 1, which really isn't going to change much, because now we're going to have -2c plus 10c is equal to +8c. So it only really changed the sign. So this time, instead of switching the 1 and 5, we can switch the factors of 4 and do 4 and 1. And try it again. 4c times -1 is -4c. 5 times c is going to be plus 5c, which gives us a positive c. And again, that's not what we want. So this time I'm going to switch the 1 and 5 and try this here. 4c times -5 is -20c, looking promising. 1 times c is plus c, which gives us -19c. That is indeed what we wanted. So this here is our final answer. And again, we would need to include the negative. Let's look at the next one. 4n squared minus 49. Well, we do have two terms that are being subtracted, and if they are both perfect squares, well, yes, because what times itself is 4n squared? Well, or what times itself is 4? 2. What times itself is n squared? N. So that is a perfect square. 49 is a perfect square because it's 7 times 7. And what we're really looking at here is the difference of perfect squares, which has a formula that says a squared minus b squared is a plus b times a minus b. So for this problem here, we're really saying that we have 2n squared minus 7 squared, where a is 2n and b is 7. So we really are saying that we have 2n plus 7 times 2n minus 7. And that's it. We could have factored it out as we normally do. We can look for greatest common factor. And it's always good, even for these here, to look for it. There is not a number that goes into 4 and 49. Now 49 is still considered our third term. Since it's negative, our signs are opposite. And our factors of n squared are going to be 2n and 2n. 49 is 7 and 7. And if we checked it, we would get a middle term of 0. Now looking at this here, 169 and 144, that they are perfect squares. We could also look for greatest common factor, a number that will go into both of these. Well, we know 2 will go into both of them. 4 will, because I could factor 4 out of both. Because 4 will go into 96. 4, 16, 36, 9, x squared. If we take 4 out of 144, 4 is 36. So 4 is a greatest common factor. We could factor that out. Well, that still is fine because 49x squared is still a difference of perfect squares because 49 is 7 and 7. X squared is x and x. 36 is 6 and 6. So we could say 7x and 7x. 6 and 6, and our signs are opposite. And that's it. Now we could have looked at this here and said, okay, we can check to see, can we take the square root of both of these? And this is just a different way to do it. And it would tell us that 169 is 13. Square root of 144 is 12. So we could say 13x, not 13, sorry. Square root of 196 is 14, and this is 12. So really we would have 14x minus 12 times 14x plus 12. But 14x and 12 does have a greatest common factor of 2. We can pull out, which would leave us with 7x minus 6 if we divided both of those by 2. Same with the other one here, which would leave us with 7x plus 6. And 2 times 2 is 4. Still get the same answer. And that's it there. Now if we look at the next one, a squared minus 25b squared. Well, a squared is a perfect square. It's a times a. 25 is a perfect square. It's 5 times 5, and b squared is b times b. So we can say it's a plus 5b times a minus 5b. And that's it. Let's go on and look at the next two. Now 11 and 12 are not difference of perfect squares, but we can treat them the same way as we're doing normal factoring. The first thing we look for is the greatest common factor. And here there is not one. So we can do our 2 sets of parentheses with 3 spaces. Then we can look at our sign. So we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. So here it's positive and negative. So they're the same and they match the sign of the middle term. So we'd have negative and negative. Now we look at the factors of the first and third term. Well, the factors of a squared are going to be a and a. Now the factors of 196 are 1 and 196. We have 2 and 9 is 18, which leaves us with 6, so 98. 3 does not work. 4 does work. 4 is 16, 36 is 9, so we have 4 and 49. 5 doesn't work, 6 doesn't work. 7, so that one there we would just have to calculate. So 196 divided by 7 is 28, so we have 7 and 28. You can do 196 divided by 8, which does not work. 196 divided by 9 doesn't work. 10 doesn't work. 6 divided by 11 doesn't work. 196 divided by 12 doesn't work. 13 doesn't work. 196 divided by 13. And the last one is 14 and 14. The one I'm going to try first is 14 and 14. And if we check this here, a times negative 14 is negative 14a. Negative 14 times a is negative 14a, which gives us negative 28a, which is the middle term we wanted, so these are our factors here. Now, because they are the exact same factor, we could also rewrite it as a minus 14 squared. And that's it. Now let's look at the next one. There is no greatest common factor, so we would have 2 sets of parentheses with 3 spaces. Then we'd look at our signs. Since the third term is positive, our signs are the same and they match the sign of the middle term, which is also positive. Then we need to find the factors of the first and third term. Well, the factors of the first term are x and x. And just like with 196, 144 does have a good number of factors. We have 1 and 144. We also have 2 and 72. 3 does work. And 48. 5 doesn't work, but 6 does. 6 and 24. 144 divided by 7. 7 doesn't work. 8 and 18. 9 and 16. 10 doesn't work. 11 doesn't work. And 12 does. Well, I'm going to try 12 and 12. And lastly, we can check. X times 12 is going to be 12x. Then 12 times x is going to be plus 12x, which is 24x, which is the middle term we wanted. So this here is our answer. Now we could write it as just x plus 12 squared. Either one of these will work. All right, that brings us to 13 through 16. Now again, it says use the special product pattern to evaluate each expression, which is saying that a squared minus b squared is a plus b times a minus b. So for this here, we're saying that we have 64 plus 25 times 64 minus 25. And while 64 plus 25 is 89, we're going to multiply that by 64 minus 25. So that's going to be 39. And at this point here, we can do 89 times 39. Which is 3,471. And again, we're solving for 64 squared minus 25 squared. Now in a calculator, I can do 64 squared minus 25 squared, hit enter, and still get 3,471. Same answer. So the next one, 441 squared minus 361 squared. And we can grab the calculator and say 441 squared minus 361 squared, and enter and get 64,160. So this here is 64,160, and that's our answer. And most of these here, since we're given 2 answers, we can plug them into the calculator. So the next one, we have 1,089 Try typing that again. 1,089 squared minus 961 squared, and we get 262,400. And that's our answer. And the last one, 144 squared minus 64 squared is 16,640. And that's it for these here. So these here, we really just have to plug them in and solve, and we're done. Solve each of the following by any means. So when we say any means, we literally mean any means. And one of the easiest ways, any means, we can solve it by factoring, having it as two sets of parentheses multiplied together equals 0. And whenever I have two things multiplied together equals 0, one of them must be 0. The next way we learned was graphing. Plug it into the graphing calculator and see where does it cross the x-axis. Our third one was the square root method. And the square root method worked if we didn't have a middle term, just x, we only had x squared, or we had a set of parentheses squared. That's when it worked well. Our fourth method was completing the square. Completing the square. And our last method was the quadratic formula. And these are the 5 main methods that we have. So when we look at this first one here, we could solve it by factoring, rewriting it as two sets of parentheses equals 0. And for this here, so again, there's no greatest common factor. Then we need to find the sign. Because we have our two sets of parentheses with 3 spaces. Now, since the third term is positive, the signs are the same and they match the sign of the middle term. So we'd have plus and plus. Now we need to find the factors of the first and third term. Well, the factors of x squared are x and x. Factors of 2 are 1 and 2. Now again, just like what we did with factoring, we can check it. X times 2 is 2x. 1 times x will be plus x, which is 3x, which is the middle term we wanted. So these are the correct factors. Now when we solve by factoring, whenever we have two things multiplied together to equal 0, one of them must be 0. So either x plus 1 is 0 or x plus 2 is 0. Solve for the value of x. So here we would subtract 1 from both sides, telling us x is equal to negative 1. Here we're going to subtract 2 from both sides, telling us x is equal to negative 2. And these are our solutions here. Now again, we could have graphed this. And when we graphed it, we would type it into the graphing calculator. So I pull up the graphing calculator, we're going to hit y equals. Now I'm going to clear both of these out. But in the first one, we're going to type x squared plus 3x plus 2. And again, what I'm typing is showing up in the key history. But we have this here and we can hit graph. So this shows us the graph. And again, when we're graphing it, we're wanting to see where it crosses the x-axis. Where it crosses the x-axis is going to be our solutions. Now another way we can see it is second graph, our table. And when we're looking at the table, we're trying to find out what values of y are 0. So we're trying to find out what value of x will make the function be 0. And there's 2, at negative 2 and negative 1. So again, it's telling us x is equal to negative 2 and x is equal to negative 1. And that's it there. Now we can look at the next one. 0 equals x squared minus 9. So we could graph it, or we could use the square root method. Since there's no middle term, it means we can use the square root method. And to solve this by the square root method, we need to get x squared by itself. So we would add 9 to both sides. And if we do that, we get x squared is equal to 9. Now once we get the x squared by itself, completely by itself, we can square root both sides, because the square root and square will cancel, leaving x by itself is equal to plus or minus, because again, remember, whenever we take the square root of both sides, we have to add the plus or minus to one side. And lastly, the square root of 9 is 3, and that's our answer there. And again, if we graph this, we could go y equals, so we'll clear the first one out. We have x squared minus 9. Graph. And again, we see that it does cross in two places. And if we go second table, I'll scroll up. I do see that at -3, the y value is 0. And at 3, the y value is 0. So our two solutions are positive or -3. And that's it for that there. Now the next one, we have 1/5 x squared plus 6 equals 2x. And again, if we're solving this by graphing or factoring, or most methods besides the quadratic formula, not quadratic formula, completing the square, we do need this equal to 0. So we can say 1/5 x squared minus 2x plus 6 is equal to 0. And if you're getting stumped or trying to find one method to do it, go on and graph it. If it doesn't specify, we can always start with graphing. So on the graphing calculator, so I'll clear this out here so we don't have it. The first thing we can do is hit y equals. Now I'll want to clear that function out, and I can type it in. So the first thing we're typing in is 1/5. So fraction is alpha y equals enter, 1/5. And then we'll type x squared. Now we had minus 2x plus 6, because again, we had to move everything over equal to 0 for us to be able to graph it. So looking at this here, it doesn't cross the x-axis, which is telling us that this doesn't have any real solutions, but there still are solutions that we can find. Which means one of two things. We're either going to solve this by completing the square or by the quadratic formula. Now this is a little bit different. We didn't quite show this, especially in the lesson. But one thing we can do is multiply everything by 5 and distribute this out. Well, 5 times 1/5 is 1. So we're just left with x squared. 5 times -2x is negative 10x. And 5 times 6 is going to be plus 30 is equal to 0. Now at this point here, we can use the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And again, this is referring back to ax squared plus bx plus c. Now a, b, and c, none of these will have a variable. It's just going to be the number in front of it. So we would have negative. Well, our value of b is -10 plus or minus the square root of -10 squared minus 4 times a, which is 1, times c, which is 30, all over 2 times a. And again, at this point, we're going to simplify. So at our first one, we have -10. Negative and negative is going to make a positive. The denominator 2 times 1 is 2. So inside, we have -10 squared minus 4 times 1 times 30. So on the calculator, we can go second quit to get back here. So we'd have -10 squared minus 4 times 1 times 30. And we can hit enter, and it'll tell us that it's -20. So all this inside the parentheses here is -20. Now, part of the reason we didn't type it into the graphing calculator as a whole is because I could have said second square root, parentheses, -10 squared minus 4 times 1 times 30. Hit enter. Okay, it doesn't have a real answer. Okay, quit. And that's because under mode, Down here it's on real instead of a plus bi. Okay, I fixed that. Type it in again. Well, we do have I. It does tell us that it is an imaginary number, but it doesn't give us it as a rational expression. It gives us it as this irrational number. So, plus or minus. We do need to simplify it. Now we know that the negative, this negative here, is going to come out as I. So we can bring it out as I. Now what that leaves us with is the square root of 20. Now in the yellow calculators, our other ones, our 30xs, we can plug the square root of 20 in. And it'll tell us that it's 2 square root of 5. So it tells us that x is equal to 10 plus or minus 2i squared root of 5. And we're almost done. Because if I look at this here, well, try not to erase, is 10 and 2. Are both of these divisible, not just those two, are all three of these divisible by 2? Well, yes. So we can actually simplify, because 10 divided by 2 is 5. 2 divided by 2 is 1, so we're left with our I plus square root of 5. So our answer is 5 plus or minus I square root of 5, and that there is our answer. So that one there did have some complex answers, but we can still get to the same answer. Let's look at the next one, 4 times x minus 1 squared plus 2. Well, we already have a set of parentheses squared. So what we can do with this here is use the square root method. And the square root method says that we get the set of parentheses squared by itself first. So the first thing we can do is subtract 2 from both sides. Now the set of parentheses squared is not by itself yet, so we can divide both sides by 4, telling us that x minus 1 squared is equal to 2. Now the set of parentheses squared is by itself, so we can square root both sides. And the square root and square here will cancel, telling us that I have x minus 1 is equal to, again, whenever we take the square root of both sides, we'll have the plus or minus, square root of 2. Now last but not least, x is not by itself, so we do have to add 1 to both sides. Because that will get us x by itself. And over here we would add the 1 to the front, so we'd have 1 plus or minus the square root of 2, and that is our answer. That's all we have to do for this here. We can go on and look at the next one. Now this one here, we do have the square root method, but if we wanted to try it, we could see, because again, we're still solving it by any method, we could subtract the 8 from both sides. 5, 6, 7, 8, 13. And I set it equal to 0 to see if I could graph it. Because in the graphing calculator, we can hit y equals. We can clear that out. Because we have 2 parentheses, x plus 2 squared minus 13. Because if I'm going to graph it, I need it equal to 0. And we do see that it does cross at 2 places. But in both places that it crosses, here and here, it does not cross at whole numbers. It crosses at these fractions, these decimal answers. So we can't say or kind of determine what those are. So, okay, we'll come back over here. I can go on and erase that there. Now, because we already have a set of parentheses squared, we can use the square root method. So the first thing I want to do is get everything away from that set of parentheses squared. So we can add 5 first. So I have 2 times x plus 2 squared is equal to positive 13. Now the next thing we'll do to get the set of parentheses squared by itself is divide by 2. Those will simplify to 1, telling us that x plus 2 squared is equal to 13 over 2. Now 13 over 2 does not divide evenly, so we'll just leave it as 13 over 2. At this point here, I'm going to square root both sides. Here the square root and square would cancel, telling me x plus 2 is equal to plus or minus. Now to simplify this here again, I'm going to use the 30xs. and plug it into that calculator as the square root of 13 over the square root of 2. And it will simplify it for us to the square root of 26 over 2. And we can plug that in because we prefer to leave it in radical form instead of as a decimal. And I will tell you guys this now, if you change it over to a decimal into decimal form, I will want you to add and subtract these. So here we would subtract them. These would cancel out, telling me x is equal to -2 plus or minus the square root of 26 over 2. Because again, we could have typed it into the calculator as second square root of 13 alpha y equals enter over 2 and gotten this here, 2.549 going on. But if we turned it into that decimal, we would have had to have said x is equal to -2 plus that decimal number and gotten the answer. So for us, it would have been, make sure, -2. So -2 plus second square root alpha y equals enter 13 over 2. And we would have had to put 0.5495 or 0.55, 0.55. We'd also had to have done x is equal to -2 minus that decimal number, which is just taking this same thing minus, which is -4.55, and getting this here. I'd prefer this answer, but if you do turn it into a decimal, you're going to have to answer and simplify the whole thing. All right. Okay. The last one, x squared plus 100 equals 0. Now we can do the square root method because there's not a middle term. We can also graph it. And if we graph it, clear this out here so that, again, you can see the keystroke history. We can first type y equals. We'll clear that out. Now we have x squared plus 100. Enter. Graph. It doesn't cross the x-axis. If we look at the table, there is no place, unfortunately, that this does cross the x-axis. So, okay. We can pull this back up and we can solve it by the quadratic, or by the square root method. And the square root method is the first to get x squared by itself. So we'd subtract 100 from both sides, telling us x squared is equal to -100. And again, at this point here, since x squared is by itself, we can take the square root of both sides. Now the square root of x squared is x is equal to plus or minus, because again, we need the plus or minus whenever we take the square root of both sides. Square root of -100. Since there's a negative inside the square root, it's going to come out as I. Now what that leaves us with is the square root of 100. And in this case, in either calculator, it's going to tell us that it's 10i. And even the graphing calculator, second quit, if I take second square root of -100, because I have it in a plus bi form, it'll tell us that it's 10i. Now we do need the plus or minus, but it will tell us that x is equal to plus or minus 10i. And that is it. Now we can look at this last one here. Now it is kind of set up in completing the square form, because if we want to try graphing it, we could add 100 to both sides and see what we get, which would be y squared minus 24y plus 244 is equal to 0, because whenever we graph, we need it equal to 0. So we can say, and instead of y, we'll use x squared, minus 24x plus 244, hit graph, and again it doesn't cross the x-axis. And we look at the table, all the values here are massive, because the numbers do come down a little bit, so 136, 135, I'm just looking at the y values as they decrease, but then they go right back up. This is not going to cross the x-axis. So we can look at this here. Now we can do this by completing the square. And if we do this by completing the square, the first thing we can do is subtract 144 from both sides. Well, the actual first step is a equal to 1, is the number in front of the variable that's being squared 1. In this case, it is. The next step is to get the constant terms by themselves. So here we would subtract 144 from both sides, and we want to leave 2 spaces. Because again, we want a set of parentheses squared. Our next step is to find the value of c, so c is equal to b over 2 squared. And our value b in this case is negative 24. So we'd say c is equal to negative 24 over 2 squared, which is negative 12 squared. And negative 12 times negative 12 is 144. We plug 144 on both sides. Well, that's actually back where we started. And then we would factor. Now, whenever we factor this, again, we're wanting to find the value of c to make it a perfect square trinomial, which, incidentally, it already was. And what goes in place with the y is whatever we have in the parentheses before we square it. So here we'd have negative 12. And well, negative 244 plus 144 is, well, negative 100. Now at this point here, we can take the square root of both sides, because the square root and square will cancel, leaving us with y minus 12 is equal to plus or minus, because again, whenever we take the square root of both sides, we have to include the plus or minus. Square root of negative 100. Well, the negative is going to come out as I, and the square root of 100 is 10. Well, we've already done this once before, because we can pull the negative out as I, take the square root of 100 in either calculator, and it'll tell us it's 10. Whenever I'm doing the square roots, I normally use the TI-30XS, our little yellow ones, because it'll leave it in radical form. Our next thing to do is add 12 to both sides to get y by itself. And it tells us y is equal to plus or minus 10i. And that is our final answer. That's all we have to do on those there. So this one here, we have to solve these by completing the square. Now our first step is a equal to 1. If not, make it so. So here our first step is looking to see is a1. Well, a, again, we're talking about ax squared plus bx plus c. So here a is 2, so we have to make it 1. So we're going to divide everything by 2. And when we divide everything by 2, 2x squared divided by 2 is going to be x squared. Negative 12x divided by 2 is going to be negative 6x. And negative 24 divided by 2 is negative 12. Is equal to 0. So that was the first step. Second step, get constant terms by themselves. And leave 2 spaces. We're also kind of saying that we want the x squared and x terms to be on one side also. So here we're going to add 12 to both sides and leave 2 spaces. So what that gives us is x squared minus 6x plus blank equals 12 plus blank. Because the whole point or the whole goal with completing this square is to be able to write this quadratic as a set of parentheses squared. Essentially, we're trying to get it so that we can use the square root method. Now, the third part is to find c so that this works, and c is our b over 2 squared. Then plug in. And when we plug it in, we're going to plug it in on both sides. Now for us here, normally we can do this off to the side. We don't have to do it right here. We can find c. And c in our case, I'll write it right below the step. C is equal to, oh no, I don't like it right there. So c is equal to b over 2 squared. In our case, the value of b is negative 6. So we have negative 6 over 2 squared. Well, negative 6 divided by 2 is negative 3. And negative 3 squared is positive 9. Now again, the value of c is always going to be positive. So that takes us through steps 1 through 3. Step number 4 is to factor and solve. So we want to factor our x squared minus 6x plus 9. And incidentally, we will have a set of parentheses squared because that's how this is going to factor. And we need it to factor to a set of parentheses squared so that we can take the square to both sides and solve this here. And it's always going to work out that what goes into this parentheses with our variable is always going to be what we have before we squared it. So here we have negative 3. So inside this parenthesis here was going to be x minus 3 squared. On the other side, we're going to add 12 and 9, which would give us 21. And last but not least, we're going to solve. So we're going to square root both sides, and here the square root and square would cancel. Telling us x minus 3 is equal to plus or minus the square root of 21. And again, at this point here, I would plug this into the yellow calculator. I would plug it into the 30xs and see, does the square root of 21 simplify? And well, surprise, surprise, the calculator will just throw back the square root of 21, so it doesn't simplify. And last but not least, we do need to get x by itself, so we can add 3 to both sides. Telling us x is equal to 3 plus or minus the square root of 21. And that's it. That is our final answer. All right. Let's look at 25. We're going to do the exact same thing, but here is a equal to 1. Now, one of the big things you're going to say is, well, the negative 50 is already on the other side, and that's fine, because again, we're not solving it by graphing or the quadratic formula where it has to equal 0. If you remember, our second main step is to get the constant term by itself. Now, if this had been 30 and this had been negative 50x, then we do need to move it. But here, the constant term is already by itself, so that's fine. But our first main question is A, our term in front of x squared, is it 1? Well, no. So make it so. So we have to divide everything by 5. So 5x squared divided by 5 is going to be x squared. 30x divided by 5 is 6x plus blank is equal to negative 50 divided by 5 is negative 10 plus blank. I'm going to go on and add the blanks, adding our blanks because, well, the constant term is already by itself. So step 2 is also finished, which moves us to step number 3, finding the value of c, b over 2 squared. And this time our value of b is positive 6. Whole 6 divided by 2 is 3, and 3 squared is 9. Incidentally, both of these worked out that the c value is 9. Step number 4 is to factor and solve. And again, what goes inside the parentheses with x is going to be whatever we have inside the parentheses before we square it. So we have the 3. Since the 3 is positive, we're going to have plus 3. On the other side, we have negative 10 plus 9, which is negative 1. And the last part is solving, so we're going to square root both sides. And on the one side, the square root and square would cancel, leaving us with x plus 3 is equal to plus or minus, because anytime we take the square root of both sides, we have to add the plus or minus. And the square root of negative 1 is I, because by definition, I is the square root of negative 1. That's just by definition. And last but not least, we do need to get x by itself, so we would subtract 3 from both sides, telling us x is equal to negative 3 plus or minus I. And that would be our final answer. All right. Let's look at 26 and 27. Now with the quadratic formula, well, we're looking at x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, when we use this here, we do need it equal to 0, and we can solve it from this here. So when we look at the first one here, we do need this equal to 0, so we can add 5 to both sides, which will tell me that we have negative 4x squared plus 3x plus 5 is equal to 0. Now we don't have to worry about the fact that the a value, the 4, is negative. If we don't want to deal with the negative value of a, that is fine. We can multiply or divide everything by negative 1. I could divide everything by negative 1 and that would fix it. Now, I'm going to go through once and show you what happens if we leave it as negative. I will also go back through again and show you what happens when we leave it as positive. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, this is referring back to ax squared plus bx plus c. So in our case, b is positive 3. So we have negative 3 plus or minus the square root of b squared, so 3 squared, minus 4. A in our case is negative 4. And c is positive 5. All over 2 times a, 2 times negative 4. Now we just need to simplify. So our first part, negative 3, is just negative 3, plus or minus. The denominator, 2 times negative 4, is negative 8. Square root. I would plug everything inside that radical into a calculator. So we have 3 squared. Well, hold on. Helps if I get out of that. Clear this out. So we have 3 squared minus 4 times negative 4, which is our a, times 5. Hit enter and we get 89. So we can come back over here and say 89. Now again, at this point here, I would plug the square root of 89 into a calculator, into the yellow calculator, and see, do we get a nice number? If we do, or it simplifies to something else, awesome. If not, we leave it as is. Now we're not quite done because, well, let me get the highlighter back. We can't leave the denominator as negative 8. We've got to move that negative. So what I can do is I can multiply the numerator and denominator, or I can divide everything by negative 1. And essentially all I'm doing is moving this negative up to the top, which will just be negative 3 plus or minus the square root of 89 all over 8. And we multiply that negative through. Negative times negative 3 is 3. And we multiply the negative by that plus or minus. Well, it just ends up being plus or minus. So we get x is equal to 3 plus or minus the square root of 89, all divided by 8. And that is our final answer. And that's all we have to do for this one here. Come on. There we go. I'm going to erase all this here. So, well, again, I'm just adding the 5 back over just so we're back to where we start. X squared plus 3x plus 5 is equal to 0. But this time, I don't want to deal with that negative. So what I could do is divide everything by -1, which will tell me that I have 4x squared minus 3x minus 5 is equal to 0. Now this doesn't change it, because again, we said x is equal to mine just based on what we just found, 3 plus or minus square root of 89 all over 8, because that's the answer we just found. And this here is going to give us the exact same thing. We just won't have to deal with the pesky negative. There we go. Because again, if we plug it in, negative b plus or minus the square root of b squared minus 4ac all over 2a. In our case here, we have negative b. Well, again, ax squared plus bx plus c. Well, b in this case is not positive 3, it is negative 3. Times negative 3 squared minus 4 times a. Well, a in this case is positive 4. And c in this case is negative 5. All over 2 times a, 2 times 4. And again, just like before, we have to simplify this. Come on. Here. So if we simplify it, well, negative, negative 3, negative, negative makes positive. 2 times 4 is 8. And if we plug this in, again, I wouldn't plug it in with the radical. I'd say negative 3 squared minus 4 times 4 times negative 5. And even though that the 4 is now positive and the 5 is now negative, and the 3 squared is now negative 3 squared, we still get square root of 89. And if we plug that into the graphing or into the 30xs, it'll still tell us that it is 3 plus or minus the square root of 89 over 8. It's just going to tell us that that doesn't reduce. So we get this here, and that'd be our final answer. All right. Let's look at this next part here. We're going to look at the next one. And we're looking at negative 7x squared plus 6x plus 4. So we're going to solve this here. This time, I'm just going to add 4x squared to both sides. Because again, if we're using the quadratic formula, we need this equal to 0. These are going to cancel out to tell me that it's 0. On the other side, I have 4x squared minus 7x plus 6 is equal to 0. And again, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, this is referring back to our ax squared plus bx plus c. And for this first part here, negative b, or b, so we have negative. Our b value is negative 7, plus or minus square root of b squared, so negative 7 squared, minus 4 times a. Well, a in our case is 4 times c, which is 6. And again, we take the sign with it over 2 times a, 2 times 4. And again, just like the one before, we're going to simplify this sum. So negative 7 is just going to be 7. 2 times 4 is 8. Square root. We can type this in. So we have parentheses, negative 7 squared minus 4 times 6, I believe. And hit enter, and it gives us negative 47. Now again, just like with the other calculator, we would plug this in to see if this would simplify. And I would plug, well, negative 47. The negative is going to come out as I, which leaves us with the square root of 47. And again, I would take the 30xs, type it in, and see does it simplify? No, it does not, so we get the square root of 47. So again, if there's a negative inside that radical, you're going to need to bring it out as I. I will take all points if you don't bring that negative out as I. So that is it for those two there. Find and describe. So find the value of the discriminant. Well, our discriminant is our b squared minus 4ac. And if it's greater than 0, we have two real solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if b squared minus 4ac is less than 0, we have two complex solutions. So we need to find all three of these parts here. So the first thing we're going to look at is this here. And to find it, we do need this equal to 0. I'm just going to subtract 4x squared to both sides. 0 is equal to negative 4x squared plus 5x minus 10. Now, again, we're not solving it. So the fact that a is negative is not going to throw any hindrance. We're not going to have to simplify it out of our final answer. We can just plug this in and find out what b squared minus 4ac is, and then figure out what type of answers we have. Now for us here, the value of b is positive 5. So we have 5 squared minus 4. Well, a is negative 4, and c is negative 10. Now again, at this point here, we can plug it into a calculator. We can say 5 squared minus 4 times negative 4, negative 4 times negative 10. Enter, we get negative 135. There's one part of the answer. That is the value, b squared minus 4ac. Now, since it's less than 0, it's negative. We have two complex solutions. That's the other part of our answer, and we are done. That's all we have to do for this year. All right, let's look at the next part. So number 29, we do need to get this equal to 0, so we would subtract x from both sides. Minus 2x squared minus x minus 6 is 0. And again, we're going off of our b squared minus 4ac. Now for us here, the value b is in front of our x. Now since there's not a number there, it's understood to be 1. Or in this case, it would be negative 1. Now here, the value of a is in front of the x squared, so it would be negative 2. And the value of c is our constant term. And again, we're going to type this in. So we'd have parentheses, negative 1 squared minus 4 times a, which is negative 2, times c, which is negative 6. And hit enter. And incidentally, we get negative 47. So there's the value of our discriminant. Since it's less than 0, we have two complex solutions. And that'd be our answer. Now we could go through and use this to solve the quadratic equation. I'm not going to ask you to do that on the test. It does include it as part of the answer key. So if you wanted to find the solutions or use the quadratic formula to find the solutions for these here, you could go on and do that as well. But we're not going to do that here. Now the last one we have, again, we do need to get this equal to 0. So what I could do is subtract 24x from both sides. 0 is equal to, we can say negative 48 minus 24x minus 3x squared. Now for us that's a little bit backwards because normally we have the x squared in front, followed by x, followed by the term without a variable. And again, we're trying to find out what the value of b squared minus 4ac is. And this is referring back to our ax squared plus bx plus c. And our first one is b. So in this case, we have negative 24 squared minus 4. A in our case is negative 3. And c is our negative 48. And we could type this in. So we'd have parentheses, negative 24 squared minus 4 times a is negative 3 times c is negative 48. Hit enter and we get 0, which means we have one real solution, because if it's equal to 0, it's one real solution. If it had been a positive number, it would have been two real solutions. And that's all we're looking at for these here. Nope, I'm going to be back here. All right. Let's look at the next part. It's finding the value of c and factor it. Well, c for any of these here is b over 2 squared. So we're taking the b value. So here, negative 24. C is equal to negative 24 over 2 squared. Well, negative 24 divided by 2 is negative 12. And negative 12 squared is 144. So we found the value of c, which means that this here is x squared minus 24x plus 144. Now the last thing we need to do is factor it as a set of parentheses squared. And again, the number that goes inside the parentheses when we factor it is whatever's inside the parentheses before we squared it to get the value of c. So here's going to be minus 12. And that's it. We can look at the next one. Again, we want to find the value of c, which is our b over 2 squared. And this time it is positive 29. And if it doesn't square nicely, we'll leave it alone. So here we'll just leave it as 29 over 2. And again, at this point here, we could type this into a calculator. So we could say parentheses, alpha y equals enter 29 over 2, close parentheses, squared, hit enter, and it'll tell us that it's 841 over 4. And that's our value of c, really telling us that we have x squared plus 29x plus 841 over 4. Now this here will factor, and we'll have x. And just like the one before, whatever we have inside the parentheses before we square it will be what goes inside the parentheses here when we factor with the same sign. Since it was positive, it's going to be plus. Now that brings us to our last one here of these three. So at this point here, c is equal to b over 2 squared. Our value of b is 49. So we'd have 49 over 2 squared. And again, because it doesn't simplify, we can type it in, alpha y equals enter, 49 over 2, close parentheses, squared. Hit enter. We get 2,401 over 4. Which tells us that we have x squared plus 49x plus 2,401 over 4. As a set of parentheses squared, we'd have x. And again, whatever we had in the parentheses before we square it is what's going to go in here. And these here would be our two answers. And that's all we have to do on these here. All right, that brings us to the last section, simplifying each I term. Whenever we simplify powers of I, we have one of four cases. is we can take I to the n, and whatever the power is, we'll divide it by 4. If we get that the decimal is 0.25, it's going to simplify to I. If the decimal is 0.50, we get -1. 0.75 is -I. And 0.00 is going to simplify to 1. And that's all we have to do for any of these here. Now for the first one, we have 27. So in the calculator, I'm going to clear all this out again. We're going to have 27 divided by 4, which tells us that it's 6.75. I really don't care too much about the 6. It's the 0.75. Since we have a decimal of 0.75, this reduces to -I. And that's it. That's all we have to do for these here. Now we can do the next, same thing for the next part, I to the 287. So I'll get the calculator, do 287 divided by 4. 71.75. I don't care too much about the 71, but because it has a decimal 0.75, tells us that it simplifies to -I. We'll do the next one, I to the 41st power. So again, I'm going to grab the calculator. Do 41 divided by 4. Hit enter. Well, it tells us it's 10.25. Well, again, I don't care about the 10, but the 0.25 tells me that it's going to reduce to I. We can look at the next one, I to the 2,874. So 2,874 divided by 4, enter is 0.5. And if 0.5 is the decimal, it reduces to -1. And last but not least, 6,971. 6,971 divided by 4 is 0.75. So this one here is -I. Now, if it doesn't give us a decimal, so I'll just pick one above it, 6,972. I just picked a number, and we divide it by 4. Here, we don't get a decimal number, so we understand that it's 0.00, so it would reduce to 1, because whenever the decimal is 0.00 or it doesn't show up, it's understood to be 1. So we get this here. Let's look at the next part, evaluate each expression. So for these here, we can add and subtract like terms and solve, or we can take the graphing calculator. I'm going to clear all this out. In our first one, we'll type it in exactly as we have it. 6 minus 7 second decimal gives us I, close parentheses, plus parentheses 4 minus 3 second decimal gives us I, hit enter, and it tells us it's 10 minus 10I. And that's it. That's all we have to do for all these here. So for the next one, I can say parentheses 7 second I, close parentheses, well, not close parentheses, minus 27 close parentheses, plus parentheses second, 3 second I minus 2. So even though I came first this time, doesn't matter. Calculator is still going to give us the answer, which is -29 plus 10I. And that would be the final answer. So -29 plus 10I. And that'd be it. And we can look at the next two here. So in the calculator, we can pull it up and say parentheses 6 minus 4 second I, close parentheses, minus -3 second I, plus 2, close parentheses, enter. We get 4 minus I. And that's our answer. If we look at the next one, 74 minus 6 second I, close parentheses, minus parentheses 27, minus 3 I, close parentheses, enter. We get our answer, 47 minus 3I. And that's it. Now, last but not least, we have this here, e. And again, this here, we can type it into the calculator, even with the powers. So we can say parentheses. So we have 189 second I minus 361 second I squared plus 71 second I squared minus 38 second I to the fourth. We can use the caret key, 4, close parentheses, enter, and it gives us our answer of 252 plus 189I. And that's our answer. That's all we have to do for this here. Because again, the calculator will do these for us. And the same thing is true with multiplication. So number 7, we can take it and plug it into the calculator. 7 minus 4 second I, close parentheses, open parentheses, 16 minus 2 second I, parentheses, not L, enter. We get 104 minus 78I. And that's our final answer. We can do the same thing with G. So we can say 8 minus 2 second I, close parentheses, open parentheses, 6 plus 3 second I, close parentheses, enter. It'll give us the answer, 54 plus 12I. So at this point here, we're just plugging these into the calculator and letting them do it for us. Even with 3 terms, we can still type this all into the calculator. So we can do 2 plus 3 second I, close parentheses, open parentheses, 7 minus 4 second I, close parentheses, open parentheses, 6 minus 2 I, enter. And it'll give us our answer, which is 182 plus 26I. And again, with any of these multiplication or division, with any of these addition, subtraction, multiplication, even the division, we can just plug them in. Go on and we'll do the next one. 8 plus 4 second I, but this time it's I squared, so we can type it in as I squared, times 16 minus 3 second I, this time it's to the 5th power, and that's fine. Enter. We type it in, it'll give us the answer. It doesn't care that I is to the 5th, it will still simplify it, and we get 64 minus 12I. And that's it there. Let's go and look at the next one, J. 3 minus 2I times 2 plus 3I. So again, in the calculator, 3 minus 2 second I times 2 plus 3 I. Enter. And it tells us the answer, which is 12 plus 5I. And last but not least, we already did this one. I got ahead of myself. So, because this one here wasn't actually this here, because I think I mixed the problems up. So, yes. Okay. So our 64 minus 12I is this one here. I did that one a step early. That probably confused some of y'all, because this one here (8 plus 4I times 6 minus 4I). So we can say 8 plus 4 second I times 6 minus 4 second I. Enter. and we get 64 minus 8i is what we should get. Got those confused or mixed up, I'm sorry. I did come back luckily and fix that. All right, let's look at these two here with division. Now we can still do these in the calculator, except we do have to type them in a little different. We have to write it as division first, and then turn it back into fraction. So for this first one, we have to do parentheses the numerator divided by the denominator. And again, when we divide it, we'll need the parentheses, otherwise it will not give us the correct answer. Now once we get it as decimals, we can go math, enter, enter, and it'll tell us that the answer is 14/5 minus 2/5 I. And that's our final answer. Now for the next one, again, we can say 4 divided by 3 minus 4i and type that in. So we can say parentheses 4 divided by 3 minus 4 second I, enter, and it'll give us this here. Now to get it back into fractional form, we can go math, enter, enter, which tells us that it's 12/25 plus 16/25 I, and that's our answer. So again, we can still do it in the graphing calculator. We just have to have a few steps in between. And again, when you do these here, make sure to put it in as fractions. Right? Finish your answer as a fraction. Now again, for this next one here, we can say 8 plus 3i divided by 6i. And even though it's one term on bottom, we'll still need it in parentheses when we type it in. So we can say 8 plus 3i divided by 6i, hit enter, and we get this here. One of them's not a nice fraction or a nice decimal, but if we go math, enter, enter, it'll tell us that it's 1/2 minus 4/3 I. And that's our answer. We don't have too many of these left, so for the next one, to find it, we're going to do 8 plus 4i in parentheses divided by 16i. So in here, 8 plus 4 second I divided by 16i, enter. So if we get this here, we can go math, enter, enter, which tells us it's 1/4 minus 1/2 I. And that's our final answer there. Now this one here is the last one with division, so it'd be 3 minus 7i divided by 6 minus 9i. And again, we could type this in. 3 minus 7i, close parentheses, divided by 6 minus 9i, hit enter. We get this here, and those are some pretty ugly fractions. Now if we go math, enter, enter, it will make them look a little bit nicer. So we have 9/13 minus 5/39. So we have 9/13 minus 5/39 I. That there is our final answer. And again, with any of these divisions, we want to leave it as a fraction, not as a decimal. Okay. Now there is one less part, find the conjugate and their product. So for Q, we have 4 minus 3i is what's given. Well, the conjugate, we're really just switching the sign in front of the term with I. So its conjugate is 4 plus 3i. And the last part we want to find is their product. So 4 minus 3i times 4 plus 3i. And we're going to multiply these together. Well, again, doing a calculator. 4 minus 3i times 4 plus 3i. And we multiply the conjugates together, we should just get a number. So this here is 25. So these here are our two answers for this part here are, so they give us 18 plus 14i. And again, it's conjugates, just changing the sign in front of I. So we get 18 minus 14i. And the next part, the other part of this is to find their product. So we're going to multiply them together. So in the calculator, we would have parentheses 18 plus 14i times 18 minus 14i, which is 520. So the two answers for this part are 520 and are 18 minus 14i. Last two. So the next one we have is S, which is 8i. And again, that's what they gave us. So its complex conjugate is negative 8i. And to find their product, we're multiplying 8i by negative 8i. And again, we can still type this in, 8i times negative 8i. Enter. And we get that this is 64. So our two answers are negative 8i and 64. And that brings us to the last part, T. Now they gave us negative 19i. So switch the sign in front of I, which would be 19i. And our last part is to multiply them together. Parentheses, negative 19 second I times 19i. Enter is 361. And that is everything that is going to be on the test.